It's 120 by 75K. Okay, so that equals, wrong color, whatever. Shouldn't really care about the colors too much. So that's 1.6 times 10 to the negative 3 VIs, right? So that's our short circuit current, which is actually also our Norton current. So, you know, whether we look at this box here or we look at this circuit here, the short circuit current in either of these scenarios is going to be the same. So the current coming through here is going to be 1.6 times 10 to the negative third VIs. The same as right here. You know, the current that's going to come down this way is going to be 1.6 times 10 to the negative third VIs. It's the same thing. So there we go. So that's our Norton current. Let's just put a box around this, as this is important. Oops, that's the wrong color. Put a big old box around this. That's our, I should label that as IN, because that's what I called it up here. So this is I sub n. I sub n. So then what's the other thing that we need? Well, we need to know our Thevenin. And we solved that in the last video. Let's do it again real quick. If you remember, it's not hard at all. So I'm going to have to, we're going to replace this short circuit here, all right? To do this, to find our RTH, we apply a test voltage, if you remember, to the outside here. Plus, minus, I think we called it Vx. We're going to apply a test voltage there. Oh, man. This is still in. All right. Sorry, I shouldn't have made such a mess over here. Now I have all this cleanup work to do. That was dumb. Maybe I'll remember for next time. Okay, but this is still I2. I2. We're still going to need that there. And the other thing that we do is we set VI equal to 0, right? Which effectively gives us a short circuit here. You know, this is equal to 0. Right, so you could almost, I mean, it's 0, you shorted it out. If you want to, you can remove it completely out of the circuit for this part. There you go. Right, or you could say that VI is equal to 0. I don't care. Again, notice that this branch now is shorted out. That's going to become important. Okay, so what we want to do is we want to look at what the resistance is from looking in on the outside. Let me pick a new color for this. How about magenta, if that's even magenta? Okay, I'm running out of room here, huh? Let's see if I could work with this little bit of room. So I don't want to lose the image. All right, so the first thing that we need is we also called this I sub x over here, Ix. We said it's coming this way. All right, and we said that Ix is going to be equal to beta I. I really don't like this pen sometimes. Plus I2. Right, the current coming into this node is equal to the currents coming out. So Ix is coming in, I2 and beta I are coming out. And, you know, we've done this all before. I is shorted out over here. So beta I is 0. So this term goes to 0. So what we're left with is, that's an X. So what we're left with, I don't know what that is Ix is equal to I2, where I2, I'll do that in a different color, not to confuse things. I2, again, is just the voltage here divided by the resistance. So, and coming down this way, that makes sense. So I2 is just Vx by R2. And we said that the Thevenin resistance, RTH, we said this in the previous video. I didn't say it in this one. So if you didn't watch that, you might want to go back and check it out, or just take my word for it here, is our test voltage over our test current. So RTH is simply Vx by Ix, which is Vx Ix here, which is I2, and I2 is Vx by R2, right? So let's just note that real quick. So therefore, Ix is Vx by R2. So Rx is Vx over Ix, which is Vx by R2. This is Vx by R2. Sorry, I'm getting tight here. These guys go. The R2 pops upstairs. So that's just R2. Right, so that's our RTH. Why did I put RX? Sorry guys, it's early in the morning. I haven't had my coffee yet. That's RTH. Oh man, is R2. And there we go. We have all the information we need to find the values for this circuit. So we found our IN, our Norton current over here, which we said was 1.6 times 10 to the negative third VIs. That's here. And we found our Thevenin resistance the same way we did when we were finding the Thevenin equivalent circuit here. And we found it again to be R2. R2 is just 56 kilo ohms right here. And that's all the information you need to solve this problem. So there you go. Maybe we'll do one more of these, I guess, just to really drive it home. And I hope you guys enjoyed it. Let me know by subscribing. You could rate it, like it, favorite it if you want, and please drop a comment. Let me know how I'm doing. Feedback is critical. Like I said, I can't imagine I'm doing these problems without making mistakes. So when you guys find a mistake, let me know. I mean, don't flame me. Don't troll my channel looking for mistakes, but let me know. This way I can fix them. All right? Till next time, deuces.